Hi everyone, my name is Phil. Today I'll be teaching you how to solve the 3x3 Rubik's Cube using an easy method. This method is easy because it's broken down into small steps, each with an obvious and well-defined goal. The method is designed to minimize intense thinking and memorization. In fact, the only thing you really have to memorize is one 4-move sequence and several applications of it. After watching this video, you will be able to solve the cube and also be able to teach others as well. Before we go into the method of solving the cube, let's explore some basics and background info. This is a 3x3 cube. For the purposes of our tutorial, there are two ways to visualize this puzzle. First is side by side. This cube has 6 sides, each with a different color. The centers of these sides act as swivels, and they stay put relative to each other. For example, no matter how much I mix up the cube, the yellow side will always be opposite of the white side. Secondly, you can think of the cube as layers. You can think of layers like stories in a building. Each layer sits on top of one another, except for, of course, the bottom layer. Here, the terms we will use to describe the layers goes as follows. The first layer is on the bottom, and the last layer is on the top. The middle one is what we call the second layer. The basis for our solving method is to visualize the cube as a puzzle with 3 layers. Now let's take the cube apart and check out the components of the puzzle. You'll notice that there are 3 different types of pieces on the cube. The first type of piece is called the centerpiece. Each centerpiece holds one sticker. There are 6 centers in total. Because the centers don't move relative to each other, the color of the center will ultimately decide the color of each face. For example, if the side has a red center, the entire side should be red when the cube is solved. The second type of piece is an edge which holds 2 stickers. An edge is a type of piece that fits in between 2 centers. For example, this blue and red edge fits between the blue and red centers. The third type of piece is a corner which has 3 stickers. This corner is red, white, and blue, and fits between the red, white, and blue centerpieces. Each piece is unique on the cube. There will only be one white center, one green-orange edge, and one red, white, and blue corner. Along these lines, there will be certain pieces that do not exist. For example, there will never be a green-blue edge, as the centerpieces are opposite. That's about it for background information. Now let's talk about how the cube moves. Each side can be rotated clockwise or counterclockwise. You can make a single or even a double turn. These moves on a cube can be denoted with cube notation, which begins with associating each side of the cube with a letter. The letters we use here are R, L, U, D, F, and B. R stands for right, L stands for left, U for up, D for down, F for front, and B for back. In this tutorial, we'll only be using R, L, U, and F. A plain letter means a clockwise turn of that face with respect to that face, as if you were looking directly at it. For example, a U would instruct us to turn the upper side clockwise once. A letter followed by a prime symbol means a counterclockwise turn. So a U prime would instruct us to turn the upper side counterclockwise once. If you did a U and then a U prime, the cube would return to its original state because the U prime undoes the U. Double turns are notated with a 2 following the letter. So, an R2 denotes a double turn on the right face, and doing another R2 returns the cube to its original state. Direction does not matter so much here, as turning a side clockwise twice is the same as turning it counterclockwise twice. Let's try a notation exercise. For this exercise, try doing the following moves. R, U, R prime, U prime. In plain English, this string of moves instructs us to move the right face once clockwise, then move the upper face once clockwise. After that, move the right face once counterclockwise. To finish, move the upper face once counterclockwise. If you did this correctly on a solved cube, 2/3 of your top face should still be the same color. Repeating the string of moves 5 more times, 6 times in total, returns the cube to its original state. There are a lot more types of turns and notations, but the ones mentioned in this section of the video are the ones that will be used to teach the method. At this point, we know how the puzzle works, its basic rules, and how to turn. Now let's take a look at the method and then apply our knowledge to solve the cube. For simplicity, we will break this step down into two separate substeps. The first one is called Daisy, and the second one finishes up the cross for good. We call the first step Daisy because daisies have yellow centers and white petals. The goal of this step is to gather edges with white stickers around the yellow center. For our purposes, the edges with white stickers will be called the white edges. This should take only 1 to 3 moves for each sticker, and it is completely intuitive. We feel the best way to teach this is by example, so here's an example of how to solve the daisy. So to make things easier and more visible, we recommend starting our solve by putting the yellow center on top. We will try to build our white edges around it one by one. Here, one of the white edges, the one in the back, is already solved. That means there are only 3 we have to do ourselves. From this view, we are able to see 3 white edges. Here, here, and here. This one here on the left is only 1 move from being solved. So solving it is very straightforward. Generally, our goal is to go for the easiest ones first. White edges are usually easy if they're sitting in this position or this position. They can be solved using only 1 move. The second sticker we can do here is this one. This one is not in our desired spot, but if we turn the front side this way, it is 1 move away from being solved. This one was solved in only 2 moves, and you can actually think of it as an extension of the first case you had. The first move transferred this white sticker over here, which turns it into the first case we encountered. At this point, you'll know how to solve this piece. Now it's time for the third edge. We have no more white stickers right in front of us, but we can spin the cube in our hands to try to find one. Here it is. It's sitting near the bottom of the cube. This one's a little trickier and requires more moves to solve, but we can definitely do it. The first step is to turn the top so that the empty space where you want the edge to go is on top of the edge you're looking at. Now the second thing to do is to move this sticker or this edge piece to either this position or this position. We can do that by rotating the front. You can move it this way, or you can move it that way. Let's choose to move it this way. At this point, this case is really similar to the first one we solved, which was transferring the edge piece directly up. However, this is made a little more complicated because this piece is already white and we do not want to kick it out of its position. So in order to get past this issue, what we'll do is we'll move this empty spot to where you want to put the edge. And then you can see this is exactly the same as the first edge we solved. We just do 1 move and we get it in. At this point, your daisy should all be solved. Let's do another example of the daisy. Here, as you can see, in this case, we got lucky again, which can happen pretty often in this step. This piece is already adjacent to the yellow center. From this position, we can see the 3 white edges we want to solve. This one, and this one. Now, the piece here can be solved with 1 move, which is exactly what we've been doing in the previous example. What we'll focus on next is this piece over here. To solve pieces like this, turn the front face, which gives us a very familiar setup. From here, all we need to do is make 1 move to finish it off. The last piece is also 1 move off, so we'll do that to complete the daisy. Here's one situation you may encounter while solving the daisy. This white-red edge is all the way at the bottom, which is on the opposite side of the yellow center. To solve this, simply turn this side twice to get the piece into place. Here's one last situation you may run into while solving the daisy. You have the pieces solved, but there is something remaining, like this white-red edge over here. Here you can try to solve it using that familiar technique, but you may notice that it kicks out this edge which is already solved. To remedy this, we recommend moving the empty spot over here, which will then allow you to put the piece that you want inside to complete the daisy. Now that we've covered how to solve the daisy, we will explain how to complete the second substep, which is solving the cross. The idea is to align the other color of each of the white edges with its corresponding center by turning the bottom two layers together, and then turning the front face twice when the colors match. Let's go through an example. All we must do here is find a white edge and pay attention to the other color on it. In this case, it's green. So what we'll do is rotate the bottom two layers together until the greens match. Once we know that the greens match, we can turn the front face twice in order to solve the cross piece. At this point, you can spin the cube in your hand in order to find a new piece. The first thing I noticed was this orange piece, and it's already near its corresponding orange center, so there was no need to rotate the bottom two layers together. At this point, once these oranges match, we can turn the front face twice to solve the orange cross piece. Now let's spin the cube one more time to find this red-white piece. And now we want to match the red with the red center, so we can do that by turning the bottom two layers together. And once we have that, we can turn the front face twice. Our last target is this edge, which is blue and white. So at this point, we want to match the blue with the blue center, which is on the opposite side of the cube. So we can turn the bottom two layers together 2 times in order to make the blues match. And at this point, we can turn the front face twice in order to complete the cross. That's about it for the cross. The daisy is slightly abstract and requires some thinking, so make sure you practice that a bit. At this point, you should be able to solve the white cross on your cube. The next step is to solve all 4 first layer corners, which are shown here. All of these corners should have a white sticker. Here's an example of a correctly solved corner. You can tell it's solved because all 3 of its colors match the surrounding centers. In this case, the white part of the corner is near the white center, the red part is near the red center, and the green is near the green center. This corner is not correctly solved, even though the whites match, because the other colors do not correspond correctly. Now let's introduce an algorithm, which is a series of moves that accomplishes a particular task on the cube. Here it is. R, U, R prime, U prime. This is actually the same sequence of moves we explored in the notation exercise. For review, the algorithm says to turn the right face clockwise, the upper face clockwise, the right face counterclockwise, and then the upper face counterclockwise. In this tutorial, we'll call this algorithm the righty alg. The righty alg has many uses. In this step, we'll be using it to solve the first layer corners. Here's how it works. Repetitions of the righty alg will cause a corner piece to drop from the top right into the bottom right slot. The piece goes directly down. Our goal is to get the corner piece above where it should go and then repeat the righty alg until it is solved. In this example, after confirming that the red, white, and blue corner should belong between the red, white, and blue centers, we shall repeat the righty alg until the corner is solved. Let's try it. And here you can see that after 3 repetitions, the corner is solved. Now let's do a full example. To begin, make sure that your white cross is facing downward. The white side should be facing down throughout the entire duration of this step. Here in this example, we already have a corner solved in the back, which is pretty lucky. Our first step is to look on the top layer and find a corner with a white sticker. We have one here, and it's white, orange, and blue. Now we check to see if the corner is on top of where it should go. In this case it is. If this corner was solved over here, it would match. White, blue, orange, white, blue, orange. So once we confirm that this corner should go directly down, we repeat the righty alg until the corner is solved. Make sure you check in between repetitions to see if the corner is solved. If you overdo it, you might have to do more in order to solve the corner. In this case, it took 3 repetitions to solve the corner. Now let's check the top layer to find another corner with a white sticker. There's one right here, and it's white, red, and green. Unfortunately, it's not on top of where it should go, So we have to rotate the bottom two layers together in order to put it on top of where it should go. This is very similar to when we were solving the cross. So let's do it. No. Yes. So at this point, after rotating the bottom two layers together twice, we have this in position now. White, red, green goes down into the white, red, green spot. Once we confirm this, we can repeat the righty alg until the corner piece is solved. And here it is. The last corner is white, green, and orange, and it belongs directly down in this position. So it's already set up for repetitions of the righty alg. There's no need to position it with turning the bottom two layers together. So once this is set up, we can repeat until the corner is solved. And at this point, you can see that you have a first layer that's completely solved. All the white stickers match, and you should have a ring of matching stickers around. This is when you know you're finished with this step. Sometimes you may have a corner twisted in place like this, or two corners trapped in the bottom layer but swapped so that they are incorrect. To solve the corner trapped in place, simply repeat the righty alg until it is solved. To interchange two pieces that are incorrectly trapped, simply insert a corner piece into one of these positions using the righty alg, which should kick the piece out, and reinsert it in order to solve it correctly. If you would like more help on how to fix these, please see our troubleshooting video. Once the first layer corners are done, it's time to move on to the 4 second layer edges. The 4 edges we're interested in solving include the red-blue, the red-green, green-orange, and orange-blue. None of these edges should have a yellow sticker. In this step, we'll also make use of the lefty version of the righty alg, which is this. L prime, U prime, L, U. This algorithm says to turn the left face counterclockwise, the upper face counterclockwise, the left face clockwise, and then the upper face clockwise. Remember that an L move instructs us to turn the left face clockwise as if we were looking directly at it. Here is the L move one more time for clarity. Let's call the alg we just did the lefty alg. Like the corners in the step before, we'll be moving edge pieces from the top layer into their correct spots. For example, we would like the green and red edge to appear between the green and red center pieces. This is an example of a correctly solved edge. The two colors of the edge match the centers that are adjacent to it. In this step, you'll be using combinations of the righty and lefty algs to manipulate the edges and solve them. In between these algs, we'll be spinning the cube in our hands, like this, in the form of spin right and spin left. Spin right follows the U-turn like this, and can be seen here. Spin left follows the U prime turn and goes in the opposite direction of the spin right. This is a spin left. To set up an edge to be solved, first look at the edge. We want to match the sticker facing you, in this case green, with the center of the same color. You can rotate the bottom two layers together in order to match these stickers. So for here, once we notice that this color is green, we'll rotate the bottom two layers together and match it with the green center. There are two ways to solve an edge. From the top layer, you can either move the edge to the right to solve it, or to the left to solve it. For this example, because we matched the green ones here, we can then determine that this edge, which is green and red, belongs to the left in between the green and the red centers. The other case we can have is this piece right here, and we can illustrate it first by matching the greens together. And then you can see that because this is green and orange, it goes between the green and orange pieces over here. So this would be a case where you would want to move the edge to the right. To move an edge to the right, do this sequence. U, righty alg, spin right, lefty alg. There's an easy way to remember this one. First, remember which direction the edge should go, and move the edge away from where it should go. Then, do the alg corresponding to the direction you want the edge to go in. So over here, the righty alg. Spin the cube in that direction, so spin right. And then do the other alg, which is the lefty alg. And here you can see that this piece is solved. To move an edge to the left, do this sequence. U prime, lefty alg, spin left, righty alg. You can remember this using the same strategy outlined before. Here's a walkthrough. U prime, lefty alg, spin left, righty alg. Let's check out an example. Let's start by finding an edge that we can solve. In this example, there's one right here, the blue-orange one. We begin solving the edge by first matching the sticker that's facing us with the same color center. Here in this example, the blues are already matching, which is already done for us and very convenient. Next, we determine where the edge should go. Should it go to the right or should it go to the left? After looking at it, we can decide that it goes to the left since these blues match and the edge would go here with the oranges matching as well. Now that we know this, we can apply the sequence of moves to solve the edge to the left. It begins by turning the edge away from where it should go, applying the lefty alg, spinning left, and then applying the righty alg. The next edge we can see is the orange-green one. We want to match the orange sticker on this edge with the orange center. We can do this by rotating the bottom two layers together. This edge also goes left, so we can apply the same sequence to solve it. Now we have the green-red edge, and it's conveniently set up for us. This one also goes left, and so we'll do the same thing once again. The fourth and last edge is the red-blue one. We'll move the bottom two layers together to match the blue on the edge with the blue center. This time the edge moves to the right. To move the edge to the right, begin by turning the edge away from where it should go, then apply the righty alg, spin right, and then apply the lefty alg. At this point, all of our second layer edges are solved. After this step is done correctly, it'll look like 2/3 of your cube is done. It's time to work on the last layer. The first objective here is to form a top cross like this. This step is different from the cross we solved first in the beginning. Actually, it's much easier. Here's an example of a top cross. Sometimes you can complete the first two layers and already have a cross on the top formed. If this happens, you can skip this step completely. Aside from having the cross solved already, there are only 3 different cases you can encounter. We distinguish these cases based on the pattern of yellow edges facing up. Let's go over all 3. The first one is called the line. We call it the line because the yellow edges form a line with the yellow center. To solve the line, hold it horizontally. Here's how to do it. F, righty alg, F prime. Essentially, we turn the front face clockwise, perform the righty alg, and then undo the first turn we made, which is to do an F prime. It's very easy, and as you can see, the top cross is already solved. The second case is called the angle. We call it the angle because the yellow edges form a right angle together with the yellow center. To set this one up, hold it so that there's an edge on the right and an edge on the bottom. Here, we're going to use a special type of F-turn. Instead of turning the front face on its own, we're going to turn the front two faces together. So this sequence begins with a small f, which is the front two faces together, the righty alg, and then small f prime, which is a counterclockwise turn of the front two faces together. This is the same as the previous sequence, except we involve the front two faces together instead of just one face. The last case is called the dot. We call it the dot because it's a dot and there are no other edges that are yellow that are facing up. To solve the dot, perform the sequence for the line. And then you'll notice that we have an angle, so then we can perform the sequence for the angle. And this case is just an addition of the two previous cases. This step is generally pretty easy because all it is reacting to a small group of patterns. The next step is to solve the positions of the last layer corners. Let's first take a look at what this means. Here's a cube with the last layer corners solved. You can see that each color of the corner pieces matches exactly with the centers they are near. These corners are correctly positioned. Now let's take a look at this cube. The corners on this cube are obviously not solved, but they are still correctly positioned. To illustrate, this red, blue, yellow corner is still in between the red, blue, and yellow group of centers. The corner is in the correct position, it's just twisted. The same is true of the other corners. They are in the correct position, just twisted. This step aims to correctly position all the corners. At this point, we don't care whether any particular corner is twisted or not. There are three cases that can happen, and you can adjust the cube by turning the bottom two layers together in order to get a better view to determine which case you have. Let's start with the first one, which is the easiest. If you take a look and all the corners are already correctly positioned, like in the cube we have here, do nothing. You've essentially skipped this step. The second case is where you have to swap two corners in an adjacent fashion. Let's do an example. Here you'll notice that the red, blue, yellow and the blue, orange, yellow corners are correctly positioned. You can turn the bottom two layers together to get a better view. Now let's take a look at the other two corners, especially this green, yellow, orange one. You'll notice that the green, yellow, orange is not in between the correct group of centers. Instead, this corner belongs over here in the back between the green, orange, yellow group of centers. And the corner in this current position belongs over here between the green, red, yellow centers. At this point, it should be fairly clear that these two should swap. So to summarize, these two are correctly positioned and these two should swap. To swap these corners, hold them so that they're both on the right. The yellow center should be facing up. Once you have this, we can begin doing the sequence of moves that swaps two corners. The sequence looks like this. Perform the righty alg 3 times. Then spin right, and then perform the lefty alg 3 times. Now let's do a check by rotating the bottom two layers together to get a better view. At this point, this corner is solved and correctly positioned. This corner is correctly positioned, just twisted, but that's okay. This corner is correctly positioned, and this corner is correctly positioned. So at this point, all of the corners are correctly positioned. The other case is when you need to swap two corners diagonally. Here, 2 of the corners are correctly positioned, and 2 of them are not. The corners we need to swap are diagonal from each other. To illustrate, we can notice that this corner is in the correct position, and so is this one. However, this one's not in the correct position, and this one is not in the correct position either. From here, we can tell that these two corners need to swap in a diagonal fashion, which is different from an adjacent swap. To do this, first perform the adjacent swap we learned previously. You can do this at any angle, just as long as the yellow center is facing up. Let's do this first part. After this, you'll always encounter an adjacent swap. Over here, you can tell that these two corners are correctly positioned, and these two are not. So this is an adjacent swap, and we already know how to do this. And then we can adjust the bottom two layers and confirm that all the corners are correctly positioned. Essentially, to do a diagonal swap, we do two adjacent swaps to create a diagonal swap. Now that all the last layer corners are correctly positioned, it's time to twist them so that all the yellow stickers are facing in the same direction, which is up. So essentially, you're going from this to this, where all the yellow corners are facing up. Let's try two examples. In this example, we have four corners that need to be twisted. To begin twisting them, we'll first flip the cube upside down so that the white side is facing up. In effect, the corners we need to twist are now in the bottom layer. To begin, first find a corner that needs to be twisted in the bottom layer and spin the cube in your hand so that it's on the bottom right. Here, this is not an issue because all four corners need some form of twisting. After that's complete, repeat the righty alg until the corner is correctly twisted. You can tell if a corner is correctly twisted if the yellow sticker on it is facing down. Let's try it on this corner. After two repetitions of the righty alg, you'll notice that this corner is facing down and it's correctly twisted because it matches the yellow pieces around it. Afterwards, turn the bottom layer so that another corner that needs to be twisted is loaded into the bottom right spot. Then repeat the righty alg until the corner is correctly twisted. Here we can check this corner has been correctly twisted. Repeat this process until all the corners are twisted correctly. This step ends when all the corners are twisted and the cube is turned right side up again. In this example, we'll need to only twist two corners, as two corners are already twisted correctly. To begin, flip the cube upside down. Next, confirm that the corner that you need to twist first is on the bottom right. Repeat the righty alg until the corner is correctly twisted. Here, because these two corners were already correctly twisted, we can skip them and load this one into the correct spot by doing a double turn on the bottom layer. Once this is loaded into the correct spot, we can repeat the righty alg until the corner is correctly twisted. At this point, all the corners should be twisted correctly. As a note, sometimes all the corners will be twisted correctly after positioning them. If this happens, you can skip this step. Now let's move on to the last step. Solving the positions of the last layer edges is the last step of our method. We can begin by adjusting the corners to their solved state by turning the bottom two layers together. If you did the previous steps correctly, everything should be solved except for the edges on the last layer. There are two types of cases that can happen. One type is when there is one edge solved correctly, and the other type is where there are no edges solved correctly. The first case we'll deal with is the one where one edge is solved and three edges need to be solved. To begin solving this, we must first turn it so that the solved edge is in the front. Once we have that, there is one more sequence that lets us finish the cube for good. This sequence goes like this: righty alg, lefty alg, the righty alg 5 times, 1, 2, 3, 4, 5. And then the left diag 5 times. 1, 2, 3, 4, 5. Sometimes you may need to repeat this sequence twice in order to be solved. Over here is an illustration. Right diag, left diag, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And if it's not solved, we can repeat the sequence again and it will be solved. Right diag, left diag, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And the cube is solved. The other type of case you may encounter is the one where there are no edges solved. To solve the cube from here, simply perform the sequence of moves and then spin the cube in your hand and do it again. To illustrate, let's try it. So I'll do the sequence. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. At this point, I can spin the cube in my hand so that the solved edge is in the front and do the sequence again. And the cube should be solved. So that's about it for solving the Rubik's Cube. If you understand these moves and sequences, you should be able to solve any cube no matter the scramble. Thank you so much for watching and taking the time to learn with me. For more resources, like our troubleshooting guide and some examples of the method in action, please see links in the description. We'll also throw in some other cool cube stuff in case you're interested in speed cubing. If you have any questions, feel free to leave a comment and someone will get back to you with an answer. Thank you again and have a great day. Congratulations on solving the Rubik's Cube.